Okay, so our lecture today is going to kind of go back over the charges that we learned about last lecture. If we kind of go back looking at charges, metals are generally going to be a positive charge, and nonmetals are generally going to be more of a negative charge. And this comes from our relationship between our Lewis dot diagrams and our valence electrons. So if I look back at my periodic table, we kind of had these charges and valence electrons and trends all written down previously. I'm going to have valence electrons here on the bottom, VE, and charges are on top. So if part of our misconception is where do I get the number of valence electrons? Well, that's a trend that's on the periodic table. You can easily find that. So anything that's in family 1, 1 valence electron. Anything that's in family 2, 2 valence electrons. If you're wanting to look at charges, anything that's in family 1, positive 1. Anything that's in family 2, positive 2. And it's the same on the right side. Family 13 always will have 3 valence electrons and a positive 3 charge. And it kind of goes all the way over on our periodic table. 4 valence electrons, 5 valence, 6, 7, and then from neon down you have 8. Helium's the only one that'll have a valence electron of 2 from this family. Same thing with the charges. Plus 3, plus minus 4, minus 3, minus 2, minus 1, and a charge of 0 for your last family. These are all trends. And so if we look at that relationship, I'm going to look at sodium in A, oxygen, magnesium, and fluorine. And if I'm going to make these individual Lewis dot diagrams, I'm going to look, sodium, Na. How many valence electrons? 1. So I'm going to draw out 1 dot. If I look at oxygen, family 16, 6 valence electrons, so I will draw 6 dots. 1, 2, 3, 4, 5, 6. Magnesium, find it on the periodic table, right here. Second family, 2 valence electrons. So therefore, 1, 2 dots. Last one is fluorine, family 17, so we will have 7 valence electrons. So I will draw 7 little dots. So when we're looking at the charges and the relationships here with the Lewis dot diagrams, I'm going to look. 8 is our magic number. That's what we should remember from last time. 8 is the magic number. That's what we want. So when we look at oxygen here, and we have 6 valence electrons, how many electrons am I short from having 8? My answer should be 2. I'm 2 short. So that means I will have a negative 2 charge. If I look at fluorine, 1, 2, 3, 4, 5, 6, 7. 8 is our magic number, so how many short am I? I'm 1 short. So I have a charge of negative 1. On the other hand, looking at sodium and magnesium, both of these are classified as metals. And metals will tend to give electrons away while metals take electrons. And so if I'm looking at sodium, it has one valence electron. This one valence electron will be really, really quick to give away its electron. And generally, when someone's giving you something, that will make you happy. It'll make you have a positive attitude. So if you're thinking in those manners, our charge of positive 1 kind of makes sense because it's going to give that electron away. Magnesium, it has 2 electrons. If it gives away those 2 electrons, it'll have a charge of +2. So this is kind of where our charges are coming from. They're based off of your magic number of 8. Is it easier to take the electron, or is it easier to give the electron away to get to that number? So that's where our charges come into play. Next up was the misconception of our polyatomic ions. Ions generally looks at your charge. Atomic is looking at your atoms. Poly means many. So if I have multiple atoms, that would be my polyatomic. And polyatomics have their own names. It'll always be the set ratio. So if I have ammonium, that is always 1 nitrogen to 4 hydrogen. And it'll always have a charge of +1. Carbonate, CO3, will always have 1 carbon, 3 oxygen, and a charge of -2. So these are common polyatomic ions that we have. So if I'm going to go into my next little bit and I look at ions, ions are going to have either your element or your polyatomic, and then it'll have a charge. Either it'll be positive or negative. So if I'm looking at lithium, and I'm telling you to write out your lithium ion, I would be able to look at my periodic table. Lithium is in the first family. Charge is +1. So my ion would be Li +1. If I'm going to look at the handout that's on your Google Classroom for today, you would simply find barium. So Ba. Barium is right here, family 2. So its ion would be Ba +2. If I look for lithium, we just did that one, Li +1. Sodium, we would look for sodium, Na. Again, sodium is in your first family, so it'll have a charge of +1. If I'm going to go look for the second part, sulfide is sulfur, so S. And family 16, so my charge is -2. If I look here, sulfate is kind of strange. That looks like a strange name. So if you can't find it on the periodic table, look up here. Look in your polyatomics. And I'll find that sulfate is actually SO4. And it has a -2 charge. If I'm looking at hydroxide, hydroxide is another one that's kind of strange. So I would look up and I would try to find hydroxide up here, and I would find it right here. And I see OH, -1. So that's all you're really doing right here. As we go back over this worksheet here, this is simply going over what's called your crisscross method. And I did go over this a little bit in your last video. But all you're doing is, let's go ahead. I'm looking at your positive 2 charge on iron. And let's see if I can make this a little bit clearer. And I'm going to join it up with my chlorine. So essentially that would be Fe plus 2 and a Cl negative 1. I would take the numbers and I would crisscross them down. So I would essentially have Fe 1 Cl 2. Now 1, so you don't have to actually write 1. The most correct way to write this would be FeCl 2. And so that would be my answer. If I'm wanting to look at my next box right here, where I'd still have iron plus 2, and my carbonate, move this up just a little bit, Fe plus 2, CO3 minus 2, I would circle the numbers, and I would bring them down. I would have Fe2, CO3, and I don't want this to look like 30. I don't want this to look like 32. So what I'm going to do is I'm going to put this in parentheses. So that way I know that this is separate. So my number that I brought down would be 2. Now here's the fun thing. You can write it like this. It's still correct. But a ratio of 2 to 2, 2 over 2, is the same thing as 1. So I could also write this as FeCO3. So for today, the only thing I would really like for you to do is I would really like for this section to be complete. I would like for this section to be complete as well. Your ionic bonding and covalent bonding, we're not going to get into much more. This is more of an understanding behind what's been done. So I'm not going to require you to finish these if you haven't already. The only thing I am going to say is if you have questions on them, please let me know, so then that way I can definitely help clarify any misconceptions that you have. For this right here, I really would like for you to focus mainly on identifying the positive and negative ions. I'm not worried about you doing the formulas here. That's going to come later. For today, I would like for you to kind of finish your element, ion, element and ion, element and ion. I'm not worried about you finishing these two just yet, because when we get into our next lesson, we're going to look at how to identify covalent and ionic namings, and we're going to look more closely at the compound formula. So for today, I really would like for you to focus on identifying elements and ions. That's the one thing I'd really like for you to focus on today. So if you have any other questions, please let me know. Today's assignment is going to be a completion grade. So if there's any questions, just let me know, and have a wonderful weekend.